All right. Uh, we're here to talk about identity and access management, IAM and AWS. But before we get into the deep dive into IAM, I want to know, does anybody know what that is? I mean, of course you know what it is. It's the letter E, right? And some of you are probably looking at this over here and thinking, okay, well, it's like 2.718. Somebody taught you that once, that number. Let me ask you a question. Why do we have such a number? Like, what is that number? Why does anybody care about 2.718? Right? And this came up relatively recently in my family. I have two teenage daughters, the younger one of which just took Algebra 2. And for those of you raised in the American educational system, you probably took out this class Algebra 2 in math in high school. And they teach you a whole bunch of topics, among them, logarithms and this thing E. And so I asked my daughter, did they explain to you what E is? And she's like, yeah, 2.718. I'm like, no. Did they actually explain to you what E is? And she's like, sure, you can do this, right? You probably recognize this. This is interest compounded continually, or, it's a handy shampoo and conditioner product. That's also that. So I asked her, like, so why, what's E doing there? Like, why does this 2.718 have anything to do with it? And at this point, turns out this line of questioning is actually pretty annoying. So that's where the discussion ends. But actually, this is one of the most interesting concepts that in my opinion, that you learn in your mathematical education. But in order to understand that, and in order to really understand what this E number does and why it matters to anything, well, you actually have to understand what it is a little bit better than something about some shampoo. Well, there's actually many ways in math to learn to get at what E is. It's kind of magical that way. But this is my favorite one. And this is the one that to me explains why they teach you about this in Algebra 2. Imagine we define a function in math where the slope of the function at any given point is actually equal to what it has, right? Its rate of growth is directly dependent on what its current value is. Now, if you understand that, so that's, I kind of tried to draw that in PowerPoint. I'm sure I didn't quite succeed, but they might have told you later in calculus that e to the x, the function e to the x has this property. But that's why it's so interesting. It's because the value of the function at any point is its own rate of growth, and that describes a lot of natural phenomena. And if you understand that, you can get an A in math without understanding that this is why 2.718 is even a number anybody cares about. But you can be a lot more effective with this concept if you have this picture in mind. So, no, this is not a talk about math. I wish it was a talk about math, but they don't let me talk about math here. I work for AWS. My name is Becky Weiss. I am an engineer at AWS. I worked on a number of products around AWS, among them IAM. And this talk is going to take that same sort of first principles approach to IAM as I just did to 2.718, to E. Right? This is IAM from first principles. For those of you who know this term, we're about to do IAM the hard way. Now, that's not to say that this is hard. And in fact, having gone through not just the what to do, but the how it works and why it works, my hope is that you come away from this a lot more effective at writing all of those IAM policies, which are your first line of defense of securing anything you do in AWS. It's my opinion that learning how to effectively read and write IAM policies is the number one biggest leverage skill that you can invest in teaching yourself to use the cloud effectively, because every service is IAM. It actually gives you a really good insight into how and why the service fits together is the kinds of policies that it has. And IAM is a skill that once you apply it, once you learn how to do it once, you know how to do it for all the other AWS services. So, this is less a talk about exactly how to put together an IAM policy, but don't worry, we can't really talk about the first principles here without lots of examples. So you are going to see them. So going to kind of do this IAM the hard way, but what this talk really is, because I myself, I've worked for AWS for a total of about 8.5 years, and I wasn't born knowing IAM. I kind of learned about it along the way myself. These are some of the things I kind of wish I had known. These are some things that actually, as I've talked to many customers over the years about how to use the service effectively, some of the kind of aha moments that I had. You're like, oh, it works that way? e to the x, why it's e. And also, oh, of course, we're going to spell, it's important to me to spell things correctly. There's principal and there's principal. We're going to talk about both of these in this hour, and it's always going to be spelled right. That's my quality promise to you here. Okay. So this is really why. This is why you see IAM work the way it works, and sort of the principles from which that starts. Now, why IAM works the way that it works actually starts in a place that maybe you wouldn't have expected me to start here at a security conference at AWS. Because I'm actually going to start by talking about some of our core principles about building these highly resilient, highly available, mega-scale services on which all of these services run. Because this is a whole topic unto itself, and it actually is directly related to this concept of authorization in AWS. Okay, so I'm going to start by introducing a few concepts. Some of you have probably seen these concepts before, and some of you may not have. So I'm just going to define a couple terms. I'm going to be throwing around these terms, control plane and data plane, because they are the two most important terms in availability at AWS. I'm giving you my own definitions here. These are terms of art from the world of networking, right? Like these words come from the world of networking, where, think about a router, right? A router on a network. Well, it is a day job, right? Day job of a router: packets in, packets out, all day long, lots of packets. Packets in, they match a set of rules. Based on the rules, we send it out this way, right? That is the data plane of the router. That's the router doing what routers do, routing things all day long. Now, of course, this router has rules. Somehow they got there. Sometimes they add rules, sometimes they change rules, sometimes they delete rules. And all of that machinery is the job of the control plane. So that's control plane and data plane. If you look at any technical system, any service, you can probably spot control planes and data planes in them. And we think very carefully about this in AWS, because the key insight here is these services, they all have a control plane and a data plane. And the jobs of these respective parts of these services are shaped quite differently. They often operate at different scale, often the data plane operating at a much higher scale than the control plane. Different levels of simplicity and complexity. The data plane's often much simpler than the control plane. It's doing a lot of things, but it's doing things a lot, but they are simple, whereas the control plane, a lot of moving parts there. And therefore, because of what I just said, although both are held at AWS to extremely high availability standards, they are actually built to different targets. They're built in different ways from each other. So I'm going to give you an example. I'm going to start with EC2 because that's actually the easiest service in which to visualize the difference between control plane and data plane. And I have some great PowerPoint animations here. So if if you're not interested in control planes and data planes, at least you can admire the animations here. So this is the data plane of EC2, right? I'm a customer. I got 2 EC2 instances, or 200, but I'm just showing you 2. And they're running. My application is running on them. It's serving traffic from my users. And, they have connectivity. That's the network data plane working. These instances are supposed to be talking to each other. They're sending packets back and forth. So that's our data plane in EC2. Now, of course, in EC2, one of the the E in EC2, it's for elastic. So that means we're going to scale up and scale down, which means that one day someone's going to come along, or more typically an auto-scaling group will come along and decide that it's time for you to get a new EC2 instance. So how does that work? Well, an API call gets made to the EC2 service. The API call is called run instances. I'm requesting a new EC2 instance. And from the perspective of a customer, you call this API, and very soon thereafter, an EC2 instance appears. Now, if you think about that for just another second, you realize, oh boy, a lot of systems had to kick into gear in order for this instance to show up, right? If you know anything about EC2, you asked for a VPC subnet. It's in a particular availability zone. You asked for a particular instance type. So EC2 now needs to go find a data center in that availability zone with space for the EC2 instance type that you requested. Maybe you probably asked for block storage, an EBS volume. So they've got to provision an EBS volume there too and attach it up to your instance. You probably asked for an IAM role to have its credentials delivered to the EC2 instance. We'll mention that a little bit later. So there's a system that goes and does that. Oh, and also, right, you're going to expect this EC2 instance to have connectivity within your virtual private cloud, within your VPC to all of the other instances. And this is an overlay network, which means there's mappings that need to be distributed via control messages to all of the other instances in your VPC so that they can all find each other. After you do that, they have all this connectivity, and it is great. Look at that. So I just used a lot of words to describe what happened, and I didn't even go into the half of it, by the way. As you might be able to tell, that is a much more complex system. It does more things than the EC2 data plane. And in AWS, when you think about the resilience of our systems, we draw this really bright line between these two halves of our system, control plane and data plane. I'll get to what that bright line means in practice in just a minute. But, we're not here to talk about EC2. We're here to talk about IAM. And, well, you're familiar with the IAM service. You call it in order to create identities, roles, users, policies, etc. And you might be wondering, well, what's the data plane of IAM? The truth is, there's no API that you call that is quite the data plane of IAM. The data plane of IAM is actually internal in AWS. Every time you make an API request to any of these services, anytime you make an API request to any of these services, the first thing that happens is authentication and authorization. Are you who you say you are, and can you make this request? Well, that's the data plane that sits behind all of the other control planes and data planes at AWS to be able to make that happen. And we're going to talk a little bit about what this data plane actually does and what comes out of it, because it's very helpful to understand for thinking about writing these policies in practice. But in case this fact is lost on you, this service is the most important availability and resilience service in AWS. So each of our respective regions has, I'll call it the auth data plane because it's an internal facing service. It's not any service you'll ever look at or call its APIs. And, of course, there's a control plane that goes with it. The control plane is exactly what you think. APIs that you call on the IAM service, like create role. Now, this is, while the data planes are in each region that you're respectively using, the control plane of IAM, there's one for all the regions, in your partition of AWS. And you call and that's so that the identities that you create in IAM's identity system so that they work in all of the regions. So you make these API calls to IAM, you ask for a role to be created, you ask to update its policies, etc. You call this service, and then what happens is there's a system of propagation that propagates out your changes to the respective regions. Now, there's a little nuance here. For regions launched before our Hong Kong region in 2019, your IAM will propagate to those regions after that, like newer regions, are on an opt-in basis, right? So you choose whether you're going to use the Cape Town region, and if you're going to use the Cape Town region, you opt into it, and then the IAM propagators take the data that is needed from your control plane over there. Okay, so this is how control plane and data plane works in IAM. It actually affects a lot of what you see as you're looking at an authorization in AWS. And again, here's the bright red line. We obsess over that red line. Separation of control plane from data plane. The control plane has more things going on. The data plane has an even more important job. Okay. So how do we think about separation of control plane and data plane? Well, there's a term that we use internally for this. It's called static stability. Now, I used to think static stability was just a word that we invented at AWS, meant stability, which is something that we were looking to do. And it actually has a definition out in the world. I looked it up. It's a definition talking about something about torque, and, happy to talk about math, also happy to talk about physics, but maybe not today. What does it really mean at AWS? Well, it really means dependency is not destiny. These static stability principles, which I'll talk about for the next minute or two, are what allow a data plane in AWS to make use of the data that comes from a control plane, to depend on its data, but without linking their availability destinies, because this data plane has to operate to a much, much higher availability target than the control plane. So I thought, what kind of visual graphic could I do here? Well, I've got this boat. Boat's data plane is going back and forth on this little lake here. And what static stability means is that even if the lake goes away, the boat keeps going the way it was. How's that for an analogy? I guess that's okay. All right, but I'm going to sort of give a quick example. Here's a very simplistic microservice architecture, System 1 and System 2. So what happens? Your user calls System 1. System 1, in order to respond to the user, needs some data from some other system, System 2. So it makes an onward call to System 2 to request that data and whatever database System 2 happens to be sitting on. System 2 returns the data. System 1 maybe does some transform over it, and then a response gets returned to your user, right? Very simple. Typically, you will build a system like this if you have a microservice architecture. It's a good way to build because it's nice and simple. It does have one consequence, though, which is that if System 2 is broken, then so is System 1, right? The destiny of System 1 is strongly linked to System 2, and in fact, a little bit more math. The availability of this system is strictly less of that of either System 1 or System 2, because I took numbers that were less than 1, even if they're only marginally less than 1, and multiply them together, they go down, right? That's how this works. It's often perfectly appropriate. But let's say I needed this system to be more available than System 2. Well, how would I do that? Well, this is kind of the pattern of achieving static stability when you need System 1 to be more available than System 2. You have some process. Now, it could be push, it could be pull. We have all these patterns at AWS, across AWS. They're all there. Somehow you're getting System 2's data into System 1. System 1 has a local view of System 2's data. What's the nice thing about this? Well, when your user calls System 1 assembles its response out of System 2's data. And the cool thing about that is System 2 can now be more available than System 1. If System 1 is having some kind of availability problem, browned out, not working, network isolated, something like that, System 1 is still working. Now, of course, System 1's not getting updates of this data from System 2, so it's becoming a little bit more stale over time. But sometimes that trade-off is exactly what you want. Another trade-off in this system that we're actually going to be talking about in IAM, you're probably spotting this already, is that the system on the left, while its availability is a little bit lower, the data is fully up to date, right? You make a change to System 2, it's there, right? Where the system on the right, there is going to be a little bit of eventual consistency, right? There's always going to be a little bit of a lag between when you make a change to System 2 as to System 1. Okay, so how do we think about static stability in these services that we have control planes and data planes? Well, in EC2, right below the red line, that's where you as a customer of AWS, that's where your application is running on. As you're serving, requests from your customers off of these EC2 instances, or doing whatever processing it is that you do, that is strictly stuff below. You need the stuff below the line working. You only need the stuff above the line working. You're going to scale up or scale down. So we think very carefully about making sure that this picture is true. Right? In the very unlikely event that there's a problem with the control plane, the data plane, which is your stuff operating on a continuous basis, that thing is still running. And likewise, in IAM, same thing. That was System 2 on the left. And we need System 1, that auth data plane, that centrally important availability service in AWS. We need that thing running at a very high availability target. So we think very carefully about, again, the very unlikely event that there's a problem on the left-hand side of this picture, having that red line there. Okay, so what does this mean to authenticating and authorizing your request? So everything that happens in it, we're going to walk through. Again, this is an IAM the hard way talk. We're going to walk through a request in AWS in pretty great detail. Talk about all of the data planes that get involved here and how exactly it is that we make these things so available. So the first thing, when you make a request to AWS, you got to be somebody, right? You have those credentials. Typically, you don't handle those credentials. The SDK or command line interface or even the console is doing this for you. But the request gets signed by your credentials as a way to prove that you are this IAM identity. But actually, before that, what is an IAM identity? In AWS, in each AWS account is its own little identity system. Each AWS account has IAM principals, PALS, in them. Users and roles. We're mostly going to talk about roles here because um, I'll mention users by the by, but IAM roles with their short-term credentials, these are far and away what you're going to use in most modern use cases. We also have IAM users. They have long-term security credentials, which means that those credentials need to be guarded quite carefully because, well, they're long-term credentials. The IAM user is kind of a standalone identity that doesn't depend on getting in there from some other identity. And actually, with our recent launch of Roles Anywhere, that probably many of you have noticed, that lets you use temporary credentials even on your on-premises AWS services. Anyways, an IAM role, this is a principal, an identity in that account's identity system that identifies itself with temporary security credentials. Okay, so what kinds of things can get these security credentials to be an IAM role? Well, one thing we use roles for is systems, right? Your applications. Any of the AWS compute environments that you're going to run code on, so that's EC2 instances, Lambda functions, ECS container, ECS tasks. And the list actually goes on into a lot of sort of special purpose things like glue crawlers, SageMaker notebooks, EMR clusters, etc. These compute environments where something's going to run on your behalf, the compute environment that they run on makes IAM role temporary credentials available to them so that they can have whatever permissions you assigned. And that way you don't have to be spreading around long-term credentials. This is, is a very convenient and very secure way to get an identity onto a compute environment. So that's one class of identities. Now, of course, IAM roles are also used by people, you, employees at your organization who are taking actions in an AWS environment in one way or another, like either in the console or CLI. Now, of course, typically in an enterprise environment, you have an identity in your company's directory, right? Maybe an Active Directory, maybe, and those are sort of the credentials that identify you as an employee of this organization. So you'll have this directory. In the directory, people are in a directory are often organized into groups. You're a member of this group and that group, and you work on this project, and you have the, this attribute. And the pattern by which you can use those directory identities to be able to obtain temporary security credentials for these roles, it's called federation. Lets you start from one of these identities and wind up in an IAM role temporarily in one of these accounts. So we have in AWS, our service that does this is AWS Single Sign-On, which is actually also now known as IAM Identity Center. And it does this job. You can connect it up to, your Azure Active Directory or to Okta, or you can create identities within the thing itself and map those identities based on group memberships and other things into IAM roles. So that's really nice because your operators are then all signing in with their directory credentials rather than having to juggle other credentials with which to get into AWS. So this is Identity Federation. There are other solutions for Identity Federation out there, like Active Directory Federation Services. You can set that up. You can build your own. All of these patterns exist out there. IAM Identity Center is sort of our solution to that. It's very useful. Recommend taking a look if you're not already using it. And with this, actually, it can convey quite a bit of information about who you were in the directory. So the user authenticates here. They wind up with the role here, and it can even add additional context. For example, map attributes from your directory into AWS. Useful because then you can refer to those in your IAM policies. Talk about it a little bit. Okay, so the rest of this talk, now that we've authenticated you and we know who you are, we're going to go in detail into this one very, very simple request. I have an IAM role of some kind. It's going to call S3 get object. It would like to read the contents of an object from S3. So it's going to call the S3 service. And of course, the first thing the S3 service needs to do is it needs to make sure that this request is correctly signed, that you actually are who you're representing to be. Okay, so if you've ever looked into how AWS requests actually get signed, you'll notice that with a role, there's sort of a trio of credentials that, a trio of values that get used to form an AWS request. There's the access key ID, which is not a secret. Which is not a secret. So I have one right here. There's the secret access key, which, as the name would suggest, is secret. And then there's a session token, which is usually a much longer blob, base64 encoded blob that contains information about the IAM session that you're running under. And actually, if you can look under the hood, you can see, like, if you turn on the --debug in your CLI, you can actually see what's happening here. I'll point out some of the things that are a direct result of this SIG-v4 signing process. So over here, you'll see the session token that will be there in a header, X Amazon security token. Access key ID, that's right there in the authorization header. Secret access key, well, that's a secret. It doesn't actually go with your request. It's sort of implied. It was used to make an HMAC signature of the request that AWS will check on the other side. And that's how your request gets signed. All right, now S3, how does this request get authenticated? Because the S3 data plane, because this is a get object is an S3 data plane request, but S3 doesn't actually have this information, right? That information, originally it came from the IAM control plane, right? This principle and its policies and so forth. So first thing S3 needs to do is it needs to go to this internal, in the same region, auth data plane to do authentication. And essentially what happens here is it sends a request up to the auth data plane and says, is this valid? Who is this? And this auth data plane is built to have an availability level that can support the availability demanded by S3's data plane. So this is data plane talks to data plane, even though some of this data came from your control plane. And what's the result of that? The result of that is the auth data plane validates the signature, and assuming it's valid, returns a whole bunch of information to S3 about this principle, about the caller. And I have only a few examples here. You'll see here that, the auth data plane can tell us the account of the principal, the AWS organization that account is in, all of the organizational units that's a part of. If the caller is part of an identity that represents an AWS service, which it's not in this example, it has that value there telling you that, yes, this is an AWS service. All kinds of tags, right? If you've ever used IAM, you've probably taken a look at the attribute-based access control ABAC functionality, and that's all done with tagging the IAM principal in the session. And all of that comes down from the auth data plane in this super available, statically stable way. And we're starting to build up a request context. We now know a whole bunch about who's calling. We don't yet know whether they can make the call, but we got a bunch of context on who's calling. So S3 hangs on to that for a second. And then we got to figure out, can they take this action? All right. Now, so here we are. We're going to make this request over here to read an object from S3. And, if you've been using AWS for a while, you know that there's actually quite a few authorities who get a say in whether this is going to be allowed or not, right? I'm going to go through each of them in turn and talk about the respective kind of data planes and availability characteristics and therefore why they do what they do. But first of all, if you're making this request from a virtual private cloud, from a VPC, and you're making use of a VPC endpoint to S3 or whatever other service that you're calling, and your request takes a network path that goes over that VPC, there's a policy you get to put in there. So your network gets a say on whether this request can happen. What else gets a say? Well, your AWS organization, right? There's a feature called service control policies that are attached to various points in your organization, potentially multiple of them in a hierarchy. Well, they get a say too in whether you can make this request. Who else gets a say? Well, the IAM principal, you put some policies on that to say what it could do. You also might have taken advantage of a sort of advanced feature of IAM that's a boundary on that, right? Somebody may have defined a boundary around what this IAM principal can do. Uh, if it's an IAM role, there's a session. That session itself can have a say in what can be done during this session. So that also gets a say. And S3 also gets a say. The administrator of this S3 bucket attached a policy to it. And that's another policy that gets a say in whether you get to make this request. Now, so that's at least, I don't know, six or so things going on here. And I've got a little secret for you. This is sort of the central insight here. If you understand this, you're going to be very effective at writing IAM policies and making use of all of these features that you see yourself being able to use in IAM. Your request has a bunch of different properties associated with it. There's the action you're taking, there's properties of the principal. We looked at those a minute ago, properties of the resource, properties of the network path taken. And that's really all there is to it. S3, with the help of Auth and various other data planes in AWS, has assembled what we call a request context. It has assembled a property bag that fully describes every aspect of your request. And then what happens is a series of string matching operations. Your policies have these JSON statements in them. They kind of look like this with a few details missing. They're basically a collection of statements. And these IAM, it's very simple from here on out. These statements, order doesn't matter because all of the rules here are, commutative. These statements, some of them say allow, some of them say deny. Some of them will match the properties of this request that you're making, and most of them won't. And for the ones that match, we need an allow and we need to not see a deny. So that's how this works, right? Take this example. Imagine I have 4 statements in the policy documents I'm evaluating in this round. Let's say only one of them matches the request because the other ones are matching on other criteria that aren't so in this request policy. But the one that matches happens to say allow. Well, that's good. We're going to allow this request. Likewise, if 2 of these statements match and one of them said allow and deny, these rules. The statement's going to be denied because anytime we hit a deny, it's over. And then finally, it's also possible that we go through this round of evaluation and it turns out none of the statements there match the criteria. The criteria in the various statements here, none of them match the request property, so nothing is matched. That's also a deny. You'll see us call that an implicit deny as opposed to an explicit deny. That's basically the rule here. I mean, we go through this round after round after round, making sure that it's each round that needs to allow it is allowing it. Okay. So this request context, we already started building it in the authentication step. We've got all kinds of properties of the principal here, the caller. But there's a lot of other stuff that get matched to these policy statements, right? There's the action, S3 get object in our case. There's properties of the resource that we're accessing. In S3, this would be a bucket or an object. Now, these happen to come, all of these properties get populated. The only service in the world that knows these properties is S3, right? S3 is storing all of this data in the data plane, the same sort of systems it needs to consult in order to actually read your data for you. So all of this comes out of the S3 data plane, so has exactly the same availability characteristics as the rest of the S3 data plane. So there's a lot of properties of the S3 object you're trying to read, right? Like the bucket is owned by some account. The object may or may not be tagged in some way. The object may or may not be encrypted in some way. You get to make rules about all of that. And then finally, there's the network path taken. Your request got to S3 through, well, one of 2 ways. Either it reached S3 over a VPC endpoint that was in your, the request originated in a VPC or in a network that was connected to your VPC and came to S3 by way of this VPC endpoint, this private endpoint to S3, or it came in by way of S3's public internet-facing endpoint, s3.amazonaws.com or s3.region.amazonaws.com. And that information, from our network data plane is also present on the request. What I'm showing you here is what's there if it came in over a VPC endpoint, but if it came in over the public endpoint, that's not there. But what is there is is the source IP address. Source IP is the public IP address from which the request arrived. So you have some information there about network path. This is also a property of the request that you can write authorization about. So I've got this giant property bag, different aspects, different characteristics of this request. And now what I'm going to do is we're going to go through various rounds of policy evaluation to figure out whether you can make that request. And we're going to start with the network, that VPC endpoint policy. Okay, so you are here in our various authorities of authorization here. Okay, so what happens when a request arrives over a VPC endpoint? The administrator of the VPC may have set a policy about what can happen. I'll show you an example of something that's useful to do there. One thing I see a lot of customers do with their VPC endpoint policy is write a very simple rule that says, hey, if you're using this network to make requests to S3, because a VPC endpoint to S3, if you're using this network, I'm going to require that all callers be from my organization. It's just an assertion of something I expect, right? I'm not expecting other identities to show up in my network and be calling S3. That's unexpected, so I'm just going to exclude that possibility entirely. Okay, now, those of you who know something about policies and least privilege and haven't seen a VPC endpoint policy before, you might be looking at this policy and wait, like, hey, that doesn't look so least privileged to me. It looks like she's allowing a lot of things, right? You know, is this VPC endpoint going to allow any identity in my organization to do anything? And no, that's not the case. This is a boundary policy, which means we need to pass it to continue on to the other rounds. But this is never going to give you the final answer on whether you can make this request. Now, if we didn't pass this, right, if somehow we had an identity that was outside my organization, try to get its credentials into the VPC and use the VPC, you'd get an implicit deny here. It wouldn't match that statement. It would be denied, and then we'd be done here. The VPC doesn't allow it, so we're not even going to continue on to the other rounds. So as a pro tip with these VPC endpoint policies, these tend to be fairly coarse-grained, like what you're seeing here. I would say that while, it's the same property bag in every round and any policy you write there could work, I would say if you're starting to get into very detailed VPC endpoint policies, you might be doing it wrong. You might want to save those more least privileged policies to some of the later rounds and use this sort of as a coarse-grained boundary around your network. Okay, so we got through the network. Next thing we're going to get to, the organization. The organization administrator gets a say on whether you got to make this request. So a service control policy is just a quick primer on what these are. An organization is a hierarchical grouping of accounts. Organizations contain organizational units, which can contain organizational units, which can contain accounts. And so I have a very simple organization here, 2 OUs worth of 2 accounts apiece. And the thing you can do with this from there's a lot you can do with an organization I'm not going to get into here. But the thing you can do with an organization from an IAM perspective, the IAM integration with organizations, is service control policies. So service control policies, these are IAM policies, follow all the same rules of all the other IAM policies. And they can be attached anywhere in the organization. Organization units, individual accounts, which I'm not showing here. And they're done in a hierarchical way, meaning that if I have an IAM role in this account, making that request to S3, we go up the hierarchy, account, OU, organization, and pick up any policies that are attached anywhere there. We got to pass each of them, right? Each of these gets a say in what we do. So I'm showing multiple policies here because actually it could be going through multiple rounds. And where do these come from? Well, as we authenticated the IAM principal, our auth data plane also knows about the relationships between these accounts and organizations and policies that were there. So as part of that step, again, all statically stable, all data planes, these policies got delivered down to S3 so that this could be evaluated. Okay, so what's a typical thing I might do here? I'm actually going to highlight a relatively recent launch in IAM that you may or may not have noticed. We launched this a couple months ago. It's called Resource Org ID. You can look it up when we're done. What it is, it's a nice IAM simplifier. This IAM property or IAM request context indicates the organization that owns the resource I'm asking about. So here somebody's requesting an object in an S3 bucket. resource org ID will be set to the value of that property will be the organization that owns the bucket. There's also a resource account that does something similar, resource OUs that does something similar. And this is very useful because it means, it's often the case that when somebody's writing data to S3 in your organization, you probably want to make sure that they're writing to an S3 bucket that you own, because if it's an S3 bucket that you own, it's an S3 bucket that you control exactly how it's shared. You got your block public access on it. You have your good security practices applied to this bucket. So I might, so your organization administrator might write a statement like this. If they're trying to write data to S3, we're going to prevent them from doing so unless I know that they're writing it to an S3 bucket that's under my control. So this is an example of something that might make sense in an organization service control policy. Now you'll notice, why did I do this backwards? In our last example, of course, I just had this coarse-grained allow statement. It's because actually the way service control policies work is they are expressed in terms of these deny statements. In fact, if you go and look at them, you'll see that there's a statement at the top, allow everything. It doesn't actually allow everything. This is a boundary policy. You got to get through this gate, right? And so it starts with this broad allow, and then you express your invariance in terms of deny. So you got to get a little bit good at the double and triple negative here. Okay, so our organization says this is okay. I'm accessing, actually I was calling get object, so that put object thing isn't even going to match. But even if I was doing a put object here, let's say the bucket's in the same organization, so it didn't match that deny statement, I get to live another day. So all right, now we're going to go on to the principal. Actually, first we're going to talk about various things that restrict what the principal can do. Boundaries. All right, so the first thing I'm going to talk about is the IAM permissions boundary. This is a fairly advanced feature of IAM, and it serves some very specific use cases, but I'll just sort of go over what it does. By the way, that's a property. The permissions boundary is something that you set over in the IAM control plane. You called IAM APIs to make that happen, and therefore it comes out of the highly available auth data plane, again at authentication time. And I'll give you an example of something you might use a permissions boundary for. These two, I would say, tend to be pretty coarse. A permissions boundary is really great when you have operators in your accounts that you want them to be able to create and define IAM roles and policies, but you don't want to give them sort of carte blanche to write any policy that they want. Concrete example, let's say you have a developer in your account who creates Lambda functions. And of course, if you ever created a Lambda function, you also need to create an IAM role to give the Lambda function the permissions to do the things that it does in AWS, which at minimum is going to be, write those logs into CloudWatch logs so that you can debug it, and then probably other things that the application might do, read this data from S3, interact with this DynamoDB table. So you tend to have a pretty broad understanding of the boundaries in which you want, colloquially, the boundaries in which you want these developers to operate, right? These developers should be writing policies that let you do stuff in S3 and let you do stuff in CloudWatch logs, but probably not policies that change the configuration of your VPC. That would be inappropriate for the Lambda functions that you're expecting in your, in this example in the organization. So you might write a permissions boundary here that's pretty broad. Again, it's a boundary, so it's not actually allowing these actions. It's just saying, so long as they're taking actions on S3 and CloudWatch logs, we're going to let them continue. And if it's something else unexpected, we're going to block it there. So I'm going to get back to the principal policy, but we're going to move on to the next one, which is the session policy. This one's especially interesting. So if you've ever looked at the assume role call, the STS assume role call. So this is the API call in AWS through which you get those temporary credentials so that you can operate under an IAM identity role. And you'll notice, if you look at that API, you'll notice that there is an optional parameter where you can specify a policy. Now this policy, it's effectively a boundary policy. It gets ANDed, it gets intersected with the policy that's on that role that you're assuming. Now, sometimes you'll use this and sometimes you won't, but it's very useful in some specific scenarios. I'm going to give you an example here. Another thing you'll notice, you remember when we looked at that trio of credentials and we saw that session token, that base64 encoded blob? If you go home and experiment with this, you assume some roles and you make session policies with the roles, the longer your session policy is, the bigger that token will be. In other words, this one's even more available than a data plane because it's not even in any of our data planes. These sessions are completely stateless from the AWS perspective, meaning that that policy, that boundary policy that you're sending along with your request, actually gets sent along with each request. Now, there's kind of two categories of reasons why this is very handy functionality when you want it. One is, there are some patterns. These tend to be sort of more advanced patterns. I see them more actually in my work with customers of S3 who might have some complex authorization entitlement scheme to the data that they're keeping in AWS in S3 that for one reason or another, the scale of it is such that it kind of requires more. It requires more policies than we actually have room for in the IAM control plane. Often useful to assign these dynamically on the fly. So you'll see these architectures where customers build these brokers, where actually before starting a session to request data from S3, you actually first go to this broker and say, hey, I'm going to start a session to access, these prefixes. And this vendor will actually give you a session that has those permissions, scoped to those. So it lets you create sessions that are scoped even more narrowly than the role itself. So here's an example, right? This session here is just letting me do get object from these two prefixes for whatever reason. These can be generated on the fly. They can be generated at a very high rate. They're really, practically speaking, you have to get to a pretty high rate before you hit any limits in how quickly you can do this. So this really helps you kind of scale out, particularly for data scenarios, your IAM strategies. But there's another thing that these session tokens are very useful for. They're going to make you a much more powerful user of AWS, and that's debugging. So this is a little skill here. I'm sure we've all been in this situation, I certainly have, where you're trying to get a least privilege policy working, right? Now, as any good developer, there's a little bit of trial and error as you're, trying to figure out what to put in there so that it works correctly. Okay, so let's say I tried this. I'm trying to write a good policy to give me access to read the data on this path. Okay, well, this looks reasonable. This is an S3 policy. So what I'm going to do, rather than just attach this to a role, because then if you remember, there's a propagation and I have to wait for it. There's also some caching at various levels that I need to clear. If I want really fast feedback on whether this is going to work or not, I can do this. So what I'm showing you here is a little snippet of command line stuff that basically creates a session off of my IAM role with exactly this policy in it. So I assume here that the role has a broader policy here, and I'm experimenting with scoping it down. So I try creating a session with this. I can immediately make a call to S3, get really fast and conclusive results on whether this is going to work. Looks like it doesn't work. So I scratch my head a little bit. I'm like, oh, the object was encrypted. I need the statement. It's going to tell me how to do. It's going to allow KMS to decrypt the object because the object happens to be encrypted with a KMS key. I add this to policy attempt 2.json. So now I'm going to go create a second session with this new policy, see if it works, and it looks like it does. Right? So this lets me iterate really fast without waiting for things to propagate, without wondering if they actually have my new policy or they're still sitting on the old policy. Because this policy travels with each request, it actually lets me iterate very quickly. So if you want to do IAM like a boss, this is how. Okay, but we actually haven't gotten to an answer yet on whether you can read this object from S3. And that's because we were saving the best for last. These are the policies, the IAM principal policies, and the policies on the resource. These are the ones that actually might say yes. And these come from these two respective data planes. The policies on the principal, they come from the data plane of IAM, the auth data plane, and the policies on the resource, which in our case, the S3 bucket, they come from the S3 data plane, which is storing the S3 bucket policy. So first, let's talk about that principal authorization. This is just the same as what we saw before. At authentication time, the auth data plane, it also knew all these policies associated with the principal, sent them down to S3. So S3 has them. Here's a nice, very simple least privilege policy. This role, I guess, does have permission to read this object that's being requested. So that's good. The action matches, the resource matches. So we get a yes. And because this is a principal policy, this yes actually means yes. Now, of course, as you know, if the bucket is owned by a different account, we actually have to evaluate its policy as well. And that's because in technical terms, what's happening, there's actually two authorities issuing the policies. Like, you remember how I said that each AWS account is its own self-contained identity and policy system? Well, that comes into play here, because if the caller and the bucket are owned by different accounts, we actually have two authorities, which, if you think about it, just makes practical sense, right? I shouldn't be able to print up a key to your house and let myself in, right? We're two different authorities. So the policy saying yes, that's not enough if the bucket is in a different account. If the bucket is in a different account, then we also do an authorization against the resource policy, against the bucket policy. And that one's issued by a different authority in this cross-account case. That one comes out of the S3 data plane, great, because remember, when you created a bucket policy, you were talking to S3 to do that. So S3 stores that right near all of the other bucket metadata that's necessary for your data plane request to succeed. And I'm going to just give you a slightly more complex example here, like going with our example of a cross-account access. This is something you might do. The principal is that other account. I'm allowing that other account to access this bucket, and that matches, various properties of the principal that came back from the authentication data plane. The action matches, the resource matches, and I've got two conditions here. Just the network path matches. So that source VPC condition, it means that whoever owns this bucket intended for it to only be accessed through specific VPC endpoints. So no matter who you are, if you're outside those VPC endpoints, you're not going to be accessing the bucket. You also notice that I did something with tags. I'm expecting principal roles sessions tagged application foo to be able to access this bucket. Now, of course, when you're relying on tags from another account, it sort of implies that you trust the tagging standards in that other account, because that other account got to apply those tags. But that's kind of what's going on here. This is sort of a typical pattern of a policy statement on an S3 bucket that's allowing access from another account under certain conditions. Now, we just talked about what happens if there's two authorities. I bet some of you have noticed at some point that when the caller in the bucket, or caller and resource from any other service with only a few exceptions, are in the same account, you've noticed that it actually sort of appears to be an or of these, right? If the principal and the bucket are in the same account, you may have noticed that if either of these policies allows the request, then the request gets let through. You might have wondered why that's true, right? Why does it work differently when there's one account involved than when there's two accounts involved? Well, the way these policies are delivered is exactly the same way. One comes from the auth data plane, one comes from the S3 data plane. But the difference here is who has issued these policies. In this example, where the caller and the bucket are in the same account, these policies were issued by the same authority, this account. And what that means, remember, this is all just a string matching exercise, which means we take the policies that were issued by this account into a giant bucket. Or bucket probably being the wrong word because it's S3. We take them all and it's basically a bunch of policy documents with a bunch of policy statements that we evaluate in one go. And that's why a bucket policy can unilaterally allow access to the principals in the account, right? Now, of course, any of these policies gets to have a deny statement matching it, and that'll, of course, work the way you want. And there's only a few exceptions in AWS to how this works. Like, for example, if you look at like the STS assume role permission, there's a couple of places where even if they're in the same account, we sort of authorize both separately. But the general rule in AWS looks like this, what you see in S3. I'll also add, just sort of as a parenthetical, because we're here at Reinforce, and block public access is probably your most important security feature in S3. Block public access and disabling ACLs. The way block public access works, when you have the setting on that actually blocks public access, actually in this step, what's going on here is the S3 data plane, with help from our automated reasoning, is actually injecting a policy in there to block public access. It comes into play right in this authorization, along with all of these other policies. You don't see the policy, but it's being injected in there. That's kind of how the thing works. So that's why one authority, that's why it's kind of done as an or. Either of these can allow it in order for it to get allowed. Of course, neither of them must deny it. All right, so finally, that poor soul is able to read an object from an S3 bucket. And we just went into some pretty gory detail as to how this happens. But what you should observe here is it's really the same pattern over and over and over again to make this happen, right? All we did, we assembled our property bag based on various data planes in AWS, the network data plane, the S3 data plane, the auth data plane, and we assembled a property bag, and we did a few rounds of string matching on these policy documents. We started with the VPC endpoint policy, which was a boundary. We had to get through that. We then went to the organizations policy, which is a boundary. We had to get through that. We had the principal boundary if it existed. That's a boundary. We needed to get through that. We had the session policy, another boundary. We needed to get through that. And then we had the resource policy and the principal policy. These were the ones that actually could say, we do these last because they're the ones that can actually say that you are going to get access to this object. And we do those. And that's all that happens. It's the same set of properties in each of these rounds that are issued by, various kinds of authorities in your organization who want to get a say into whether you can read that object from S3. And back to this one. Well, the reason why this one describes interest compounding continuously is because it's a function of, if you think about something that's compounding continuously based on some rate, well, it grows according to how much you have at that very moment. So at that very moment, you have a certain amount. It's a rate that's based on that amount, and then you're here. Now you have a little bit more, and it's a rate that's based on that amount. That's why E is in this. That's why E is in this formula. So hopefully you understand a little bit more than you did about not just the what to do in IAM, but how it works, why it works to these high availability standards that we have, and maybe kind of a broader and deeper understanding of how to apply that when you come back from this conference. So thank you very much for coming. I hope you have a great rest of your conference here today.